Good morning everyone, myself Abhishek Ghosh and behind the camera Sudipto Mondol. The area we have chosen for explaining the field relationship between different phase of granitoids, because here we get three types of rock. Among three, two are granitoids, and third variety we are not able to explain 100% here, but we'll see how to approach towards such a rock in field. So this is the first rock type. In earlier videos we also have explained this rock, and here the hand specimen, a broken hand specimen surface of this rock. This rock we used to call in field as spotted granodiorite. Granodiorite we have confirmed from chemical analysis and petrography, and since this rock has a spotted appearance where it is foliated, it shows the stripes, black stripes of biotite clusters, and where it is non-foliated, it just give an appearance of white cheetah, means black spots or biotite clusters are plenty in this rock. Now in the hand specimen description, these are the biotite clusters. You can rub it by penknife and then you will see that biotite flakes in your hand. So these are the biotite clusters. If we look at the lens, we don't get any short prismatic black mineral or mafic mineral, which will give the indication that pyroxene is present. So there is no pyroxene, and in thin section we have also seen that there is no hornblende. So this is a normal biotite flakes clusters, these all black clusters. And now regarding the leucocratic minerals, you can see some greenish tinge are there. These greenish tinge are due to the sosseritization of plagioclase, and it has converted to epidote. So these are the spots where we can see the epidotes are present, and see, wherever you will get epidote, be sure that these are due to the sosseritization of plagioclase. So one, this dull appearance white colored mineral, and both with the greenish appearance, light greenish appearance, these minerals are plagioclase mainly. And other, this transparent to translucent, this kind of without any cleavage plane. Cleavage planes will shine in daylight, so you can see that it is, there is no shining, no evidence of shining. This almost translucent variety of leucocratic mineral, these are quartz. You can see, check here also, these are slightly translucent, means daylight or sunlight or any light can penetrate to a little distance within these minerals. So this, by this property you can identify quartz, and quartz has no such cleavage. And now alkali feldspar, this small phase, prismatic phase, near prismatic phase, since this is an inequigranular rock where more or less grains are subhedral, subhedral means two phases are distinct but other two phases are or edges are not distinct. So here you can't say that these minerals are euhedral. Euhedral means all faces and edges are well preserved. So these are subhedral mineral grains. So you can see this shining phase of K feldspar, it is not dull like plagioclase feldspar. Plagioclase feldspar and K feldspar you can differentiate in hand specimen by this appearance. Plagioclase feldspar will have dull appearance. Both have cleavage at same angle, but plagioclase has dull appearance and K feldspar has a vitreous appearance. This vitreous nature is a characteristic by which you can differentiate, and in many places you will see Carlsbad twin, but here due to small grain size it is not very distinct. So that is why you can see this rock has biotite, but in IUGS as per the nomenclature or classification scheme you have to exclude the biotite because 20% biotite is present, at least 20 to 25% biotite is present in this rock, at least in this phase. So this 25% you have to exclude for normalizing the percentage of plagioclase, alkali feldspar and quartz to plot in QAP diagram. And more or less the plagioclase is the dominant mineral, plagioclase and quartz, and very few grains of K feldspar. This one is K feldspar. Very few grains of K feldspar we can see. That is why this rock is falling in the granodiorite field in QAP diagram, and due to its special appearance it is called spotted granodiorite. Now see, one variety is spotted granodiorite and the next variety here is this gneissic rock. Why it is gneissic? Because you can see the leucocratic band, light colored band alternated with dark colored band, numerous light colored anastomosing discontinuous or semi-continuous band, and in between dark colored bands. This is very well observed. Few bands are continuous also, light colored few bands. So this is a gneissic rock, but is it a paragneiss or is it an orthogneiss? That cannot be concluded in hand specimen description, because we are not getting any minerals, metamorphic minerals, which will indicate metamorphism of pelite. Pelite means a sedimentary rock like shale, mudstone, siltstone, this kind of rocks. Metamorphism of that pelites will generate the minerals like staurolite, garnet. With higher grade of metamorphism it will form sillimanite. So this kind of biotite, plagioclase, K feldspar and quartz, this kind of mineral assemblage, it indicates more towards igneous origin. The rock is metamorphic here because of its gneissosity, because of its recrystallization, it is deformed and it is metamorphosed. But orthogneiss means whether it is a meta-igneous, or paragneiss means whether it is a meta-sedimentary. That cannot be interpreted with 100% assurance now, but still we are more inclined to the orthogneiss. So this rock is quartzo-feldspathik biotite gneiss. So this is the second variety of the rock. This is the broken surface of the rock. You can see the rock is extremely gneissous, and these are the alternate dark and light colored bands. The light colored bands are defined by recrystallized quartz plagioclase mainly, and dark colored bands are defined by mainly biotite aggregates with small amount of quartz. So this is here gneissosity is defined by such a way, and if you focus here you can get the folded structure. These are the folded structure. Small scale folds, rootless folds. These are, you can see the folded structure defined by gneissosity, and you can see the cleavage planes. These are the cleavage planes here also. These are the cleavage planes, axial planar cleavages. And this is the third variety, that is leucogranite. You can see the color. It is white color or unusually leucocratic than normal granite. That is why the prefix is used, leuco. You can see the broken surface here, K feldspar, very fine grained, not very fine grained, actually fine to medium grained, K feldspar, muscovite, biotite. The shining appearance, if you rub it, many white or colorless flakes will fall in your hand. That is the muscovite, and these are biotite. Biotite is so less, and quartz and alkali feldspar proportion is so high. It is milky white. It is giving a milky white appearance, and that is why it is called leucogranite. So now we have confirmed that there are three types of rock in a very small area. One is quartzo-feldspathic biotite gneiss, another is undeformed spotted granodiorite, and the third one is on the top. It appears like the roof of these two rocks is leucogranite. This is also undeformed. So the field relationship between these three. One very generalized idea is the rock which is gneisses or deformed or foliated, if it is engulfed or surrounded by one undeformed rock, in most of the cases the deformed rock is older and undeformed rock is younger. And since one is igneous phase, here you cannot apply the law of superposition. Means law of superposition says in a sedimentary terrain the older bed deposited at the bottom and above that the younger bed deposited. But since here this one is igneous rock, igneous intrusion has no such rule that it will occur above of older rock. It will just come from beneath, from the deep crust or mantle, or here granite is will come from deep crust, but other igneous rocks can come from mantle, and it move upward, and the buoyant force will rupture the existing pre-existing rocks, country rocks, and it will move through the wherever it will get space. And basaltic flow or dacitic flow or rhyolitic flow, these volcanic igneous rocks can occur as a supracrustal form. It can flow above the country rock, so that is different. But other intrusive igneous rocks which come from beneath of the earth, that doesn't have any rule which will follow law of superposition. So law of superposition will not be applicable here. And this is the gneissic rock, and this is the spotted granodiorite, and this leucogranite occur as a roof. And so now this leucogranite, you can see it is concealed beneath soil. It is not a horizontal body. It is very shallow dipping and less width body, nearly 30 centimeter width of this body. And above again you can see the exposure of spotted granodiorite, and within that spotted granodiorite the xenolith of quartzo-feldspathic biotite gneiss is also there. So basically along a shallow dipping joint plane this leucogranite has been emplaced. this area or this exposure is very important or very easy to understand. That is why we have selected this one. So here you can have a 3D view, two-dimensional exposure view is also there, and a oblique section is also exposed. That is why below the spotted granodiorite and xenolith of quartz-feldspathic biotite gneiss is exposed. In between, along the sub-horizontal or gently dipping, very gently dipping joint plane, this leucogranite has been emplaced later. So this is just a leucogranitic emplacement along a predefined joint plane. Now, since here the evidence is there in the form of gneissosity planes, we can say firmly that quartz-feldspathic biotite gneiss is older than spotted granodiorite. But what happens if two granites are nearly similar in age? In that case, we have to know the rule of truncation of earlier fabric by younger rock. Now, since this is gneiss and this is undeformed, by generalized rule you can say this gneiss is older and this granite is younger, because it is undeformed and it is deformed and metamorphosed as well. But in Himalaya, where neotectonic movement is there, here you may get, this is a Precambrian terrain, so that complexity is not there. But in Himalaya, that reverse exception may happen. But there are other evidence also to reconfirm that. You can see the gneissic bending. These are folded gneissic bending, and if you look at the contact here, no foliation plane you can see. There is no foliation plane, just spotted appearance, haphazard, random, because these are undeformed. But here these gneissic planes are abruptly truncated along the surface. So this undeformed member must intruded later. That is why these predefined axial planes are also truncated. So by this way you can define the younger or older relationship in field. Here is the junction. This is the quartz-feldspathic gneiss, this is the spotted granodiorite, and this is the leucogranite. So you can see this leucogranite body. Along this leucogranite body, both the gneiss has been truncated and the spotted granodiorite, that has also been truncated. This is a sharp contact. You can see the sharp contact. This is the line of contact. It is clear, probably clear. This is the line of contact. These are the gneissic planes, the traces of gneissic planes. They are abruptly truncated by the youngest igneous intrusion, and the earlier igneous intrusion is also truncated by the later one. So both are undeformed. This one is also undeformed, spotted granodiorite, and leucogranite. This is also undeformed, but the relative emplacement age can be determined by observing the truncation of both the rocks. And as I explained earlier, at the higher altitude also the same rock is exposed. So this is the last phase of igneous intrusion in the small exposure. The gneiss is the earliest member. The second one or intermediate one is the spotted granodiorite. One unusual thing here we are observing, that is why we are also explaining this at the end of the video. that in many photographs of igneous rocks in internet or in books, we can see that the tongue or the protrusion of younger igneous rocks into the older rocks we generally get. But here the case is just reverse. This is the quartzo-feldspathic gneiss we already know, and we have established by field relation that this is older, this is younger. But due to the fracture system, or due to the emplacement style, different emplacement style of spotted granodiorite into this, it forms lobes. These are the lobe-like structure. These are the lobes of spotted granodiorite. You can see the margin. This is the margin of the. This is the margin actual of the spotted granodiorite and quartzo-feldspathic biotite gneiss. And the tongue of older gneissic rocks is apparently into the younger undeformed rocks. This is the exceptional thing here we have observed than usual. So we are explaining that if it was undeformed, we could straight away say that this is the younger rock because it has the tongue into the undeformed granodiorite. But now we can see that before using or utilizing such interpretation tool, we have to be very careful and very sure that things like this has not taken place in that scenario. That is why I have emphasized this point. And here also the same situation where older rock has protruded into the younger granitoid. Here also the same situation. Basically the emplacement of younger undeformed granodiorite has taken place in bulbous pattern, and that is why these narrow saddles we are observing, which apparently appears like tongue or apophysis. And this is what a complete xenolith looks like in field. This is the margin, sharp margin. This xenolith of quartzo-feldspathic biotite gneiss is surrounded by the granodiorite, and you can see here, you can see the tongue of granodiorite into the quartzo-feldspathic gneiss. But if you look at only this portion, you will get just the reverse situation. So the point is, don't get into this kind of wrong interpretation by seeing only one part of the exposure. Geology repeats itself in exposure scale. Here you can get an exposure where one screen can cover the whole thing, but the same thing can happen in regional scale. So be careful before interpreting such things. So this is a complete xenolith in small scale, this one. So that's all about the field relationship of gneiss and two phases of granitoids. This is the gneissic body continuing from that area up to here. And thank you. Please watch our channel and please give your feedback, and please like our video and subscribe.